Okay, guys, so now we're gonna go to our third problem from this series. We're gonna do the merge to sorted list. So let's read through the problem, work through our approach. Then I'm gonna talk a little bit about the pseudocode, and then finally we're gonna code up the solution. So merge two sorted linked lists and return it as a new list. The new list should be made by splicing together the nodes of the first two lists. Kind of confusing, but I'll work through it and you guys will be ready to understand. So what he wants us to do is to get two singly linked lists. For those of you who have never heard about linked list, I recommend it maybe taking a look at some online tutorials. It's nothing complicated. So tutorials, linked list. You can take a look. Here it's in Java, but it's pretty much the same thing. It's kind of like the same notion that we did with a tree, but in the tree we had a node, right? We had a node, and you had a reference to two different nodes. So you had a left node and you had a right node. But with a linked list, you just have one reference to one other node. So let's suppose 1. So you have a value and you have a reference, just like the tree from problem 2. But in this case, you have just pointing to one direction. If you look further into data structures, you also learn about doubly synced lists, so you can also point to the previous element, and also circular linked list, but let's not care about this in this problem. So what we have two linked lists, and we want to sort them. I'll show you guys what we want. So first, I'll get the eraser. We start, which one is smaller? 1 and 3. 3 is smaller, so we'll get 1. Which one is smaller, 2 or 3? 2 is smaller, so we stick with 2. Which one is smaller, 5 or 3? 3 is smaller. So in order to get the correct order, we're gonna take out this reference to 5, and we're gonna reference now 3. We're gonna reference 3. So you change the reference of 2 from 5 to 3. Now, which one is smaller, 4 or 5? 4 is smaller, so the order is correct. Which one is smaller, 5 or 6? 5 is smaller, so now same thing. You change the reference from 4 to 5. And the nice thing about linked lists, one of its advantage of over arrays is how flexible it is. So we didn't have to go through the whole array, all the elements in the array to change the order. We just go to the element we want and we change the reference. So it has I don't want to get too technical, but the log, the O of n, the big O notation is more efficient for this scenario. And finally, we just have 6, so you point 5 to 6. So this is what we want to do. The problem is, how are we gonna do it? So let's use that approach I used in the tree problem, which is getting a simple case. We're gonna use recursion again. So again, if you're not familiar with recursion, take a look in that uh, coding bat website I mentioned, or just look up on some tutorials. It's a little bit counterintuitive, but once you get the hang of it, it's a very powerful tool. So the simple case is when we have a list with only one element and an empty list. How are we gonna return a sorted list? Well, it's pretty easy, right? Is you just return this one, because there's nothing here, so there's nothing to sort. Uh, this problem is a little bit more complicated, so I'll just show you the guys the code already so you guys can have an idea as I'm working through the explanation of what you guys should write. So if not L1 or not L2, return L1 or L2. That's what you're having here, right? L2 doesn't exist, so not L2 will be true. And we'll return L1 because L2 is not true. So as a sorted solution for this problem, we just get the elements from the L1 linked list. This is the simple case. And the else, elif and else will be our recursion. So the recursion will do the following thing. It's gonna compare the element L1 is referencing and the element L2 is referencing. If it's smaller, if L1 is smaller, we're gonna reference L2 to something. We still don't know because it's gonna call the function again. It's gonna call merge two lists again. And it's gonna call with L1 pointing to the next element. So instead of being pointing here, we're gonna be pointing to none because 2 doesn't reference anything. So it's gonna reference none, right? So now, so L1 next. So now we're gonna call the function again, but without anything. It's gonna be none. So it's gonna when you call the function again, you're gonna go to this if statement and you're gonna return L2. You're gonna return the whole L2. You're gonna return this. Why? Because not if not L1 or not L2. Not L1 will be true because we just called merge to list with L1 being none. So you return L2 and this L2 return will replace this self dot merge to list L1 dot next L2. So now L12 dot next will reference the whole L2 list. So this is what's gonna be returned. So after the recursion call, uh, it's gonna point to L2. L2 is still here, and now we have the sorted list, and finally we return L1. So you guys see what happened. So we had two lists. L1 merge two lists will be called again, but this time with a none reference. It's gonna return L2 in this recursion call, and L1.next will be set to the second linked list. And we return the reference L1, which will give us the right sorted list. And the same scenario would happen here in our first example. So you'd compare L1 to L2 to 3, 2 to 3, 5 to 3, and then you would make a bunch of recursion calls. Finally, you would get none. And that element would be returned, and you're gonna go backwards until you get a solution. So this problem shows the power of recursion. You can do a lot of interesting things. Usually recursion appears a lot in trees, in linked lists. When you have permutations, you wanna know all the possible combinations. So really work on your recursion skills. That's gonna come in handy in the future. So I hope you guys enjoyed this video. If you have any questions, just let me know. This is a little bit harder than the two previous problems we've done, and subscribe.